2, 1.
7 things you don't really need to know, but probably should. I'm Jamie East, and this is the Sunday 7.
In today's episode, there's promising new research for multiple sclerosis, scientists are leaving COVID high and dry with the help of the humble cannabis plant, and gene editing is coming to the UK. But first, it was on this day in 2020 that China locked down the city of Wuhan and its 9 million people in an effort to control the city's COVID-19 epidemic. 2 years later, we're still working on getting that pesky virus under control.
7.
Multiple sclerosis is a progressive neurodegenerative disease that affects nearly 3 million people worldwide. Despite decades of research, the cause of MS has remained a mystery. Now, new research from Harvard points out to one of the chief suspects, the Epstein-Barr virus.
So this really has been the culmination of 2 decades of work by us and other investigators around the world.
That's Dr. Cassandra Munger, a senior research scientist in the Department of Nutrition.
I have been working in MS research for over 20 years. We have been focusing on Epstein-Barr virus and other risk factors for the development of MS.
Epstein-Barr virus, also known as EVB, is one of several known herpes viruses. It's one of the most common in humans, infecting between 90 and 95% of adults.
EBV has been particularly difficult to study because it's such a ubiquitous virus. About 95% of the world's population is infected with EBV, but MS is extremely rare. So in order to really show in sort of an observational setting that EBV is likely a cause of MS, we need to have a group of individuals who are EBV negative, who we can then follow over time to see if and when they become EBV positive. And if so, if experiencing that primary infection then increases their risk of MS.
So the research team needed a huge set of data. They analysed 62 million serum samples and medical data collected from more than 10 million US military service members, and they found that EBV infections increased the odds of an MS diagnosis during their service by more than 32-fold. Marianna Cortese is a research scientist who also worked on the study.
The way to think about it is that MS is likely a rare complication of this viral infection. We see this in other diseases, right? Or exposures. Many more people smoke than potentially get lung cancer. You can think of many more examples like that. So likely EBV infection is the most important factor that puts you on a higher risk for MS, but then there are probably other things that play a role that need to come along your life course for you to really develop that disease.
While there are some genetic factors and risk factors like low levels of vitamin D, a history of smoking and obesity early in life, EVB seems to be the common denominator. And now that the initial trigger for multiple sclerosis has been identified, perhaps it could be eradicated. While there's no vaccine against the Epstein-Barr virus yet, many groups are trying to develop one, and earlier this month, Moderna announced that it had begun testing mRNA vaccines in people.
I'm hoping to, in some years, maybe we will be able to say we can cure MS or, really give hope to so many patients and families.
For me, it really does feel like the culmination of 20 years of work, that we've been incrementally moving toward this paper, toward this study, knowing that this is what it was going to take to really show that EBV is a cause of MS.
By 2050, more than 153 million people could have dementia, up from 57 million in 2019, experts are warning. Lifestyle habits, obesity and smoking are among the risk factors likely to drive this increase. Emma Nichols from the University of Washington authored the paper. She says cases are likely to rise in every country, but researchers estimate that North Africans and the Middle East in particular are likely to see a dramatic rise.
The projections in North Africa and the Middle East were quite large, and this was due to large increases both in population growth and population aging. And so these two demographic factors in particular in that region, drove these large anticipated increases in dementia burden.
Dementia leads to a loss of brain function, thinking, reasoning and memories. Researchers say that although the numbers are not yet set in stone, they should be a warning to act now.
This is an important disease to consider in terms of future planning, no matter where you are.
Europe will probably see less of a spike, with an estimated 14 million cases in 2050 compared to around 8 million now. Experts like Dr. Carrie Harrison-Denning from Dementia UK believes this is in part due to a longer history of grappling with unhealthy lifestyles.
Healthy diets, lower alcohol intake, stop smoking. So there's this sort of mantra, look after the heart and you'll look after the head. We're now starting to see a decrease in the numbers of some dementias, such as vascular dementias. So the sort of health promotion elements of managing risk factors is starting to have an impact.
Overall, we still do need to consider the importance of any increase and preparing for the needs of this population, as well as any potential interventions and future research that can help us.
Still to come on the Sunday 7, the science behind treating COVID with cannabis and what's next for Tonga's volcanic eruption. According to new research, there's a plant that could help fight against COVID-19. It first evolved about 28 million years ago on the eastern Tibetan plateau, and depending on how you spent your uni/college days, it might look a little familiar. According to a lab study published in the Journal of Nature Products, compounds from cannabis prevented the virus that causes COVID-19 from penetrating healthy human cells.
We found that there are 3 compounds in hemp, all cannabinoids, which binds to the spike protein of the SARS coronavirus 2 that causes COVID. Then we were able to test 2 of these compounds called CBDA and CBGA, and we found that these 2 compounds are effective individually in preventing the virus from infecting human cells.
That's Richard van Breemen, a researcher with Oregon State's Global Hemp Innovation Center. While these results are impressive, Richard emphasizes that they're based on studies in a lab and not humans.
Our studies at this point are preclinical. They are laboratory-based, cell-based, in vitro experiments with cell culture and live virus. We are in the process of developing and helping to work with clinicians to establish the efficacy of these compounds in clinical trials.
And if you're hearing cannabis and getting worried, Richard says the compounds are not psychoactive. They won't get you high, and they're found to be most useful in preventative approaches.
So people who've been exposed to other individuals with COVID and need to isolate could take a pill like a cannabinoid extract and stay healthy because of the antiviral capability of these compounds. People ought not to be relying on them, say, when hospitalized with severe COVID infections. I wouldn't advocate for using cannabinoids to treat them to get well. We anticipate that ingesting these compounds as pills, tablets, that sort of thing, as dietary supplements or as pill form as medicines, will be more effective than smoking or vaping because the acid forms of the cannabinoids like CBDA are sensitive to heat.
Although cannabinoids have a long history of safe human consumption, more research is needed to determine just how effective it could be in combating COVID.
We believe that quite quickly we'll be able to move from these preclinical findings to the clinic and demonstrate efficacy in people. The reason we can move quickly is because of the experience we already have had with over-the-counter hemp preparations and extracts containing cannabinoids. I'm very hopeful that we'll see clinical evidence during the next several months that cannabinoids and cannabinoid mixtures can prevent COVID from occurring in people exposed to the virus.
On the 15th of January, Tonga's Tonga volcano violently erupted. The underwater volcano sent tsunami waves across the Pacific as far as the Russian Far East, Chile and Peru. With such a far-reaching impact, you might wonder what other effects could be witnessed from the event. After all, there's a long-standing theory that large volcanic eruptions have led to mass extinction in the past. Tieh Yong is an associate professor at the Singapore University of Social Sciences, and he explained exactly what he thinks could come next.
Now, there are two effects one can think of. One concerns the presence of sulfur dioxide gas, which by the time it enters the stratosphere, it would have been converted into sulfate crystals. We know that sulfate crystals scatters sunlight, so there is a possibility, one might imagine theoretically, that it might cool the Earth's surface because it scatters the sunlight and hence less sunlight reaches the surface. The amount of sulfur dioxide ejected is about 400 million kilograms, and that is an amount that is about 50 times less than a very famous volcanic eruptions by the Pinatubo in Philippines. And that means it cannot have as great an impact as the Pinatubo eruption. The Pinatubo eruption caused something like 0.6 degrees Celsius of cooling on the Earth's surface. So this one, being 50 times less, will not really have a substantial impact on the global surface. But there's another aspect to consider. We might worry about the carbon dioxide that is ejected into the atmosphere. Because we know that carbon dioxide is a greenhouse gas, and greenhouse gases are responsible for our human-caused global warming today. But again, the amount of carbon dioxide that is ejected is much smaller compared to the amount of carbon dioxide emitted by our industries and our transport. And so even the greenhouse warming by the carbon dioxide ejected by this volcano is negligible. So in terms of these impacts, one can be assured that not much global impact will be seen.
Still to come on the Sunday 7, scientists are tricking mosquitoes with fake blood, and we hear about how climate change is impacting everyone's favourite flightless bird. Right after this.
You're listening to the Sunday 7. Follow us for your weekday news espresso, or even try our Ireland edition. It's in all the usual places. Now, the saying goes you can catch more flies with honey than vinegar, but Swedish scientists are taking this a step further. They've developed synthetic blood to attract and kill malaria-carrying mosquitoes.
We find a molecule producing by the parasite, malaria parasite. We can add these molecules to any solution, and that molecule actually make us tasty for mosquitoes. And then if we add this molecule to other products like beetroot juice, we can make products can attract the mosquitoes. And if we add a trace of toxin in it, combined with these molecules, mosquitoes eat on it and die.
That was Dr. Noushin Emami, a molecular infection biologist and co-founder of health tech Molecular Attraction. They claim this cheaper, targeted method of pest control could be an alternative to mass pesticides that impact the entire ecosystem. Dr. Lech Ignatowicz is CEO at Molecular Attraction, and they explain.
So at the moment, the most effective way of fighting mosquitoes is still using pesticides. But we know that pesticides are killing not only mosquitoes, but also other insects and other forms of life. Plus, they're dangerous for people. So if we can use something which is as cheap and as scalable as pesticides, we can actually eliminate them. Our product is environmentally friendly because it doesn't kill other insects, and also it's harmless for people.
Mosquito-borne diseases kill more than 700,000 people every year, and malaria alone accounts for half of that.
I usually try to avoid every single weapon type of analogy, but here it's like instead of having just carpet bombing, this is more like a smart bombs which are directed into one particular target. Pesticides are killing every single insect which are coming in contact with, right? Here, even in a very dense environment, especially in the jungle environment or tropics where you have a lot of insects, we can pick the ones which we want to get rid of and target those and leave alone all the rest of the ecosystems.
This week, the UK Parliament passed new legislation that's designed to help trials of gene-edited crops in England. It's part of a gradual approach towards gene editing by the UK Department for Environment, Food and Rural Affairs after public consultation last year. If gene editing your dinner sounds a little too sci-fi for you, you've got nothing to worry about. Dr. Gideon Henderson is DEFRA's chief scientist, and as he explains,
For centuries, humans have been breeding our crops and our animals to make them better for our purposes. Nearly all of the crops and animals that we rely on for our food now have come about through this natural breeding process. And they've deviated now a long way from the native species that we find in the wild. Now, this breeding process, while very advantageous, takes a very long time. It can take decades or longer to breed a new type of crop or livestock for our advantage. And gene editing works by making very precise cuts in the genetic sequence, so you can remove particular genes from within a species, and you can potentially move genes within that species as well. It differs from other forms of genetic modification, which are more commonly used to insert genetic material from a different species into the species you're interested in. And gene editing is nearly always used to make modifications within the same species and therefore mimics closely the process of natural breeding. We can combine the traits within a species that will enable that species to be resistant to pests or to disease, and therefore enable us to lower the use of chemical pesticides in the environment with significant environmental benefits. We can also breed, using these genetic engineering approaches, crops that are more resistant to climate change.
Scientists in Antarctica have discovered that different types of penguins are facing different types of consequences of climate change. Some species are declining in numbers as the result of disappearing sea ice, while others are increasing due to rising temperatures. Michael Wethington is a researcher from the American Stony Brook University and is working on the front lines of Antarctica's changing climate. With the rest of his research team, Michael compares numbers of penguins with previous records to give an indication of how climate change might be affecting survival of different species. They're primarily looking at Adelie and Gentoo penguins.
The Adelie penguin, which has a really sort of tuxedo-like image. They're very cute and very proper looking. Gentoo penguins have a bright red beak, sort of a bright orange red beak, and a really cute white patch on the top of their heads. They're sweet as a button, and they're just wonderful to work around.
On the latest expedition, they discovered a new Gentoo penguin colony on Anderson Island, making it one of the southmost records for Gentoo penguins breeding in Antarctica.
They're more tolerant to warmer conditions that lack really heavy sea ice. We've kind of seen this as a case where you actually have a species in the face of climate change and a warming region of Antarctica, their populations are actually sort of dramatically increasing.
But for the cold-loving Adelie penguins...
When we find Adelie penguins, you typically know that sea ice is nearby, and whenever we've seen sea ice declining or disappearing altogether, then we're seeing corresponding penguin populations, or Adelies, decline substantially. While we still have time and we still have penguins existing and not going to extinction as a result of climate change, this gives us a really unique opportunity to both identify locations within Antarctica that are really important for establishing marine protected areas.
This has been the Sunday 7. Wherever you're listening, do us a favour and hit the follow button. We'll be back tomorrow at 7 a.m. with the regular Smart 7. Have a great rest of your weekend.
Written, produced and published by Daft Doris.